Okay, so here we go with the transformations of exponential functions. You will notice after you write these down, or as you write these down, that they are very, very similar to the ones we discussed last chapter. So go ahead and pause your video, write down these notes, and then let's talk about it. All right, so you'll notice that a lot of them are really familiar with the ones that we did last chapter. So like H is the horizontal shift again. Think about H, horizontal. But you have to notice H is up here. So H is going to be in your exponent. If it is your exponent plus or minus something. And the same thing, it's going to be opposite. So plus is going to shift to the left. Minus is going to shift to the right. So it's just like when we talked about everything with the radicals, but now it's in the exponent on the exponentials. But the same rules apply as far as positive is going to shift it left, negative is going to shift it right. Now K, still your vertical shift. So if something is plus or minus here at the end, that means it's going to shift it up or down. It follows the sign. So a plus is going to shift it up however many units K is, and minus is going to shift it down. Now, keep going. We are going to have, if A is negative, just like last chapter. So if it's negative times your parent function, then it's going to reflect across the x-axis. If A is bigger than 1, it's going to be a vertical stretch. If A is smaller than 1, between 1 and 0, meaning if A is a fraction. So all of this is exactly the same as what you should have memorized last chapter. The only difference is that your H is in the exponent, like we talked about first thing. Okay, so now we're looking at your first set of examples. So for the first thing, we're going to identify the parent function. In number 1, your parent function is f of x equals 3 to the x power. Does everybody see that? So your parent function is this part, which your base, with your exponent. Now we tell what the transformation is. So look and see what is added to this parent function, what is multiplied to this parent function, anything that makes it different. And the only thing we have here is this plus 5, meaning that it's going to go up 5. Okay, so let's look at number 2. Again, we're looking at our parent function first. Our parent function is the 1/4 to the x power. That's our parent function. That's what we start with. Now, describe the transformations. We have 2 different transformations happening here. We have it being multiplied by 2, and we have it being subtracted 1 in the exponent. It doesn't matter which one that you write first. So we can look at it. It's being multiplied by 2, which if we go back to our chart really quick, we see that that means it's a vertical stretch. I'll do it in something you can see a little bit better. So we're going to write down a vertical stretch of 2. And then we have the x minus 1 up here. So remember, that was the opposite. So that means it's going to go to the right one. So all of these rules are applied just like they were last chapter. All right, I want you to go ahead and do 3 and 4. Pause your video, and then when you unpause it, you'll see the answers to see if you did it correctly. Okay, so there are your answers. You see the parent function for each exponential function, and then all the transformations that are applied. Okay, so now we're looking at graphing the exponential function with the transformation. This is a little bit more in depth than what you're used to. So give me your full attention. The first thing you're going to start with is your XY chart with the parent function. Okay, so here is your first XY chart for your parent function. Now look at the transformation that's happening. It's x plus 5 in the exponent. So that means that we are going to be moving to the left 5, meaning all these x values right here need to go to the left 5. So we are going to make a new xy chart with the transformation. So -2, if we go to the left 5, that would give us -7. -1 to the left 5 is -6. And just keep going. Okay, so we are essentially just subtracting 5 from each one of these numbers in the original XY chart. So this is your transformation XY chart for this function. Okay, so now we're going to take that -7 and we're going to put it in here. And we get -7 plus 5 is -2. So 2 to the -2, which becomes 1 over 2 squared, which is 1 over 4. So 0.25. Then we're going to plug in -6, do the exact same thing. So we're going to get 0.5, and then we're going to get 1, 2, and 4. Now this is our XY chart to graph the transformation of this function. All right, guys, so there's your graph. That's the best I've got with a stylus. You can tell as it goes to -infinity, it is approaching your asymptote at y equals 0, okay? Because nothing happened to shift it up or down. It just moved to the left. So now it's time to fill out everything to the right about our characteristics and in behavior and such. So your domain, remember, is your x values. That is still all real numbers because it continues going throughout the entire x-axis. Your range, see how it's in the top of your graph. So it's y is greater than 0. In behavior, so as x approaches positive infinity, as x goes to the right, what is happening? It's going up, right here. So that means that as x approaches positive infinity, your f of x or your y is also approaching positive infinity. Now, as x approaches negative infinity, which way is negative infinity? It's the left, right? What is happening to your graph? It's just getting closer to 0. So f of x approaches 0. Now, your y-intercept. So that is hard to tell. You can't tell it right now. So what we have to do is we know our y-intercept is at x equals 0, right? So we're going to take this function right here and we're going to plug in 0 for x. So 2 times, or not times, I'm sorry, 2 and then raised to the power of 0 plus 5, which is just 2 to the 5th power, which is 32. So that means that way up here at 32 is where your graph will cross the y-axis. So your y-intercept is going to be at 0, 32. And now your asymptote, remember we just talked about it, it's still at y equals 0. So that is what will go in this blank. So again, don't let this section overwhelm you. Okay, it's just looking at your graph and writing down what you see. So remember, let's go over this one more time. First, we do our XY chart with our parent function. So here it is with our parent function. Then we look at our transformation and see how it's affecting our x values. Since this one just shifted left 5, then we shifted all of our x values to the left 5. So we subtracted 5 from everything in this column. Then we plug our new x values in, and we get our new y values. We graph, and then we just fill in the blanks for the characteristics. Now we're going to do one more together before you try it on your notes. Okay, so now let's look at one that's got a little bit more going on, okay? First, remember, we look at our XY chart for our parent function. So let's start by making it. And remember, we always use -2, -1, 0, 1, 2. plug everything in. So this time we have two things going on. We're multiplying by -2. And then we are also have the x minus 2 in the exponent. So since it's -2 in the exponent, that means we're actually going to the right 2 units. So first, plug all of that into your parent function, which is just 4 to the x power, okay? And go ahead and get your answers for your y column. Okay, so when you plugged in your x values just to your parent function right here, then this is what you should have gotten. Now, when we look at what's happening with our transformation, we're moving to the right 2, so that's what we need to do on our XY chart to graph the function with the transformation. So if we're moving to the right 2, our x value was -2. It's going to become 0 because we added 2. -1 is going to become 1, 0, 2, 3, and 4. So now we're going to take all of this, plug it in to our function right here with our transformation. So we're going to use the whole -2 times 4 to the -2 power essentially, because it's 0 minus 2 once we plug it in, and we're going to get our answers. So the first one we get is -0.125. Okay, so then we're going to plug in 1, we get -0.5. Plug in 2, we get -2, -8, and -32. All of these, when you plug it in, you can either put it in your calculator if you're comfortable with that. You can work it out on a separate sheet of paper. It's totally up to you. Once we get our XY chart from our transformation, then we can start graphing it. Okay, so here is what our graph looks like after our transformation. We notice that since there's a negative, what happens? Yes, it reflects across the x-axis, okay? It's also stretched vertically because you have a number bigger than 0 right here, -2. And then we also, like we've already talked about, we move to the right 2 units because our exponent is subtracted by 2. So now we're going to look over here and start filling in our info. So let's look at our domain first. What do you notice about our domain? So remember, domain is our x values, and we're still covering all the x values. There's no reason why we wouldn't. We're continuing on both sides, and it continues to increase. So our domain is all real numbers. Now, our range, this time it's different than the ones that we've had in the past because our graph is below the x-axis. So that means our range is less than 0. Y is less than 0. Now, our end behavior, we're going to be looking at as x approaches positive infinity first. So what is happening to our y value as x approaches positive infinity? It's going down, right? Our y value is going down. So that means that as x approaches positive infinity, your y, or your f of x, is going to approach negative infinity because it's going down. So now let's look at your as x approaches negative infinity. So as we're approaching negative infinity, your y value is approaching what? It's approaching 0 because it's approaching your x-axis. Now, your y-intercept, remember your x value is always 0 at your y-intercept. So your y-intercept is going to be 0, -0.125. So that was already done for you since 0 was in our XY chart. And our asymptote is again where? Right here at x on the x-axis. So that's y equals 0. So now what you need to do is do this for the rest of the notes. Remember, math is a skill. This is all a skill. You've got to practice it. Do it for your notes. Look at your notes, the PDF, the notes key that's going to be uploaded. I'm going to upload that as soon as I finish this video. for guidance if you need it while you do your notes. Look over it, ask questions if you need to, and then you will move to your assignment before you start the solving exponential functions. So do all of that first, this whole section first, before you move to the next one.